And Arya was like screaming in it.
Wait, was I really? Probably. She's probably really texting you, so she's like, yeah! Okay, here we go. Rational functions are of the form it looks like this. It's going to be some kind of function. And the big thing with rationals is you're dividing two polynomial functions. Okay? So, f of x equals p of x over q of x. Okay? P and q are rational or polynomial functions. Those are polynomial functions. And the big thing is q of x cannot equal 0. Why can that bottom function not equal 0? You can't have a denominator 0. Okay? It's a big thing. Okay. Now, these are the things that you're going to have to graph. Yeah. You're going to want to rewrite everything in factor form. Then you're going to want to find your x-intercepts, your y-intercepts, any vertical asymptote, any horizontal asymptote, any hole, and move from there. But you have to know when you have, so we know we have vertical asymptotes when you have anything in the denominator set equal to it. You have a hole when things cancel. But horizontal asymptotes you may or may not remember when you have them. You're going to hear me say top heavy, bottom heavy the same. Okay? This right here is considered top heavy. I'm going to ask you, hey, is it top heavy, is it bottom heavy, is it the same? Top heavy means, does my degree of my numerator bigger than the degree of my denominator? If the degree of my numerator is bigger than the degree of my denominator, you do not have a horizontal asymptote. And you'll have what you're going to learn tomorrow. You're going to have a slant asymptote, and I'll go step by step through exactly how you're going to find that. Okay? The second one, this is what I'm going to call bottom heavy. Okay? Bottom heavy. It's when your degree of your denominator is bigger than the degree of your numerator. You have a horizontal asymptote here, and every time it's bottom heavy, your horizontal asymptote is at y equals 0. No questions asked. Bottom heavy, y equals 0. Okay? Then if they're the same, why do you think I call these the same? They're equal, right? Do you guys remember what you do when they're equal and the degrees are equal? So when you divide your leading coefficients, top and bottom, so you're going to say your horizontal asymptote is y equals your leading coefficient of p dividing by your leading coefficient of q. Leading coefficient of p divided by leading coefficient of q. This is awesome. Okay? The more of these we do, the easier it gets. Let's go for that. Okay. Alright, now, number 1. First thing, go step by step on your rules. Is it already in factored form? Yes, we don't have to factor anything. Then it's asking, number 2 is asking for probably the x-intercepts, right? Okay, find your x-intercepts by finding the zeros. Now, the easiest way to find the x-intercepts is to set your numerator equal to 0. I would write that down in your notes. Right by number 2, you're going to set your numerator equal to 0. Right by number 2 in your notes on the list. Set your numerator equal to 0. So my numerator in this case is x plus 1, correct? If I set that equal to 0, how do I get x by itself? Subtract 1. So your x-intercept is at -1, 0. Agree? And I would immediately graph that. So -1, 0. Now, you can have multiple x-intercepts, but you can only have one y-intercept. Okay? Now, I believe number 3 is probably finding your y-intercept. Is that correct? I'm not going to go up now. So finding your y, that's when you're going to plug 0 in for x and solve. So if I plug 0 in for x, I would have 0 plus 1 divided by 0 minus 5. Agree? So this is the same as -1/5. Agree or disagree? That's my y-intercept. So my y-intercept is 0, -1/5. It's not the easiest thing to graph. Make it as close as you can. It's just going to be really close to the x-axis. It's fine. Just put it somewhere around there. It's not going to be perfect. It's close. You okay with me there? Step 3. Step 4. Vertical asymptotes. Vertical asymptotes. This is where you set anything left in your denominator, set it equal to 0. Do I have anything in my denominator?
Yes.
X minus 5, right? So I set that equal to 0. So x minus 5 equals 0. So I would have x equals 5. Yes? Agreed? That is a vertical asymptote. So you have x equals 5. As soon as you have a vertical asymptote, I would suggest you graph it. What does a vertical asymptote look like? Straight line, but it's dashed, right? So go to 5. 1, 2, 3, 4, 5. Make a vertical asymptote. Step 5. It's your horizontal asymptote. So now look, what's my degree of my numerator? 1. Largest exponent, right? What's my degree of my denominator? Also 1. So is it top heavy, is it bottom heavy, or is it the same? It's the same. So now you look at your leading coefficient. What's my leading coefficient in the top? So what's in front of x? 1. What's my leading coefficient in the denominator? 1. 1 divided by 1 is 1. So you have a horizontal asymptote at y equals 1. Do we have any holes? No, because nothing cancels top and bottom. Okay, now, we have to kind of like sketch this graph. So remember what happens with asymptotes. It usually comes right along and goes down. Yes? So that's what's going to happen over here. So I'm going to take this. It's going to skirt right along that asymptote. It's going to hit those 2 intercepts. And then it's going to go down. But that's not the only piece of graph for which you have. Okay? You have to find your other piece. So here's what you're going to do. Any vertical asymptote breaks up a graph. Where's my vertical asymptote at? 5. So everybody see what I mean? Is that 5? Now, I already have a graph in this direction, correct? I need a graph somewhere over here. So what you're going to do is you're going to pick a number really, really close to 5, a little bit bigger. Sure. I can do like 5.1. It doesn't matter. You're going to plug that into your function. So if I plug in 6, I would have 7 over 1. Agree? Now all you want to know is if it's positive or negative.
Why did you say positive?
Because I did 6 plus 1.
Oh,
Okay? All you want to know is if it's positive or negative. This is positive. So if it's positive, that means it's going up the asymptote, because I have to find out what's happening with the graph. So it's going to go up the asymptote. Now, you usually know that it runs right on the horizontal, but you got to make sure it doesn't come down. So now pick like 10. So if I put 10 in, 10 plus 1 is 11 over 5. Is that number getting bigger, or is it getting close to 1? It's getting close to 1, right? It's not going and getting a super large number. It's getting close to 1, so your graph is going to look like so.
what would happen? What would it look like if it was too bigger?
It'll look like a parabola. You'll see. Okay? Alright, flip it over. The more examples we do, the easier it gets. Number 2. Step 1 factor. Can I factor anything?
Yes.
What can I factor out? A 3. So I have 3, and then I have x plus 1 over x plus 2. Yeah? Okay. Now, as soon as you have it factored, check to see if you have any holes. Do you remember how you have holes? If things cancel top and bottom. Do I have any holes? No, I'm not going to have any holes, so I don't have to worry about that. Alright, don't have any holes. Now I want to find my x-intercept. How do I find my x-intercept? Set the numerator equal to 0. Find your x-intercept right now. So 3 times the x plus 1 equals 0. Divide by 3. Subtract 1. My x-intercept is at negative 1 comma 0. Okay. Set your numerator equal to 0. So you have 3 x plus 1 equals 0. Well, I got to divide by 3 to get rid of it, yes? So then I have x plus 1 equals 0. And then I would subtract 1 to get negative 1.
Oh, no.
Yeah?
I didn't.
Okay. Y-intercept. How do I find my y-intercept?
Put the bottom.
Nope.
No. Oh, yeah, plug in 0.
Plug in 0.
Yeah.
When I plug in 0, what happens with anything that has an x on it? It becomes just 0, right? So my y-intercept is going to be 0, comma, what? 3 over 2, which is the same as 1.5. So 0, 1.5. Okay, those two are done. Vertical asymptote. How do you find your vertical asymptote?
Find out if it's bottom, top, or
Nope, that's horizontal. Vertical asymptote, anything in the denominator should equal to 0. Do I have anything left in my denominator? What is it? X plus 2. Set that equal to 0. 2 would subtract 2, yes. So my vertical asymptote is at x equals negative 2. Would go with me there? Yeah? After vertical, you go horizontal. This is where you want to know. Top heavy, bottom heavy, the same. What's my degree of my numerator? 1. Degree of my denominator is also 1. Now, go back to the original equation before you factored it for your leading coefficients. It just makes it easier. What's my leading coefficient of my numerator?
Oh, wait, 3.
It's 3, right? Go back to the original. What's my leading coefficient of my denominator? 1. So 3 divided by 1 is 3. So my horizontal asymptote is y equals 3. Okay? Do we have one piece of the graph already done? You have one piece, right? We know it's going to slide along here and come down and slide. Agree? I gotta find my other piece though. Where's my horizontal asymptote at? I'm sorry, not horizontal. Where's my vertical asymptote at? -2. Now, do I have my graph on the bigger side or the smaller side? The bigger. Does everybody understand what I'm saying with that? So, the bigger side is going to be to the right of your vertical asymptote. The smaller side is going to be to the left. So I already have that graph done. So I need on the other side. So give me a number a little bit smaller than -2. No, negative one's bigger.
Oh, yeah.
Negative what? -3. Plug it in. Plug it in. So if you plug it in really quickly. So 3 times -3 is -9, yes? Plus -3 is a negative. That's all I care about. Because I don't really need the number, I just need to know if it's positive or negative. Agreed? Divided by. You.
Okay, keep going.
Plug in -3 in my denominator as well. -3 plus 2, is it positive or negative?
Negative.
Negative. Now, when I divide two negatives, it becomes what? Positive. So is this graph going to go up my vertical asymptote or down? It's going to go up because this is positive. If I can be honest with you, that's probably one of the hardest things for you guys to catch up on. Because I don't know, I think they just told you if it's in one corner last year, it's in the opposite corner. And that's not necessarily true. Hey, what?
Why? Isn't -2 down here? Or am I just...
That's positive.
I'm confused myself.
You graph positive 2 instead of -2, which is why you graph this. Alright, 3. What do I have to do first on number 3? What do we want to do first every single time if we can? Yep, factor form. X squared minus 2x minus 15. How do I factor that?
X on the outside. No.
What multiplies to -15 that adds to -2? What? X minus 5 and x plus 3. Yes? This is really going to be, can you factor or not? If factoring is not a strong suit, I love you all, but you will struggle immensely with this. Got to be able to factor. Now my denominator, is there anything to factor in my denominator at all? No, it's just x plus 3. Guys, you're not talking to me, which makes me very nervous that you have no clue what I'm talking about. Do you understand how to factor that? Do you understand that there's nothing else in the denominator?
Yes.
Okay. Now, what else do you immediately notice? You can cancel something. That means there is a hole. But now you can't just tell me there's a hole at x equals -3. You're graphing it, so you need to tell me exactly where the hole is. So, how did I get that it was -3? I set these both equal to 0 and I got -3 for an x value. Yes? -3. Now, here's one thing that they don't do in Algebra 2, I believe. Did you actually have to find where the holes were last year? I think most of you just like estimated and moved on. But that's not going to happen this year. What you now do is you take whatever x value you know the hole is, you plug it into the new simplified function. So don't plug it in here because what's going to happen? It's going to be 0. Plug it into what's left over. So what's left over in this case is just x minus 5. Yes? So -3 minus 5 is what?
-8.
-8. So my hole is at -3, -8. And I graph that. -3, -8. Boom. Now kiddos, what's left over? It's just x minus 5, right? If I ask you to graph x minus 5, can you do it? How do you graph it? What's your y-intercept?
-5.
-5. Because it's just a linear line. And what's my slope? 1. Okay. 7. What do I have to do first? Factor. Look at the numerator. 4x squared minus 9. That's the difference in two squares. So this is 2x minus 3, 2x plus 3. Yes? And then in the denominator, I can pull out a 2. Yes? And this difference in squares, right? X squared minus 1, x minus 1, x plus 1. Do we have any wholes? Why not? Nothing cancels. Are we okay with that? Yeah? No holes. What do I want to find first? X-intercepts. Always find your x-intercepts first. How do you find your x-intercepts? Set the numerator equal to 0. So take those two factors, set them both equal to 0, and solve them. So 2x minus 3 equals 0, and 2x plus 3 equals 0. So the first one you would add 3 and divide by 2, yes? So I have one x-intercept at 1.5 comma 0, and the other one's at negative 1.5 comma 0. Does everybody understand how I got those or not? Well, let's see, I guess. Where'd you guys? You were confused. So I would graph those. Graph them as best as you can. So, good. There's your two x-intercepts. After you find your x-intercepts, you find your y. Y-intercept. Now here's the easiest way to find your y-intercept. Go back and look at your original function, which is right up here, yes? Anything that has an x is going to become a 0, correct? Because when you multiply by, when you plug 0 in for x, when you multiply it becomes 0, yes?
Yes.
So what's left over on the top? Negative 9. What's left over on the bottom? Negative 2. Negative 9 divided by negative 2 is 9 over 2, which is the same as 4.5. Even totally fine. 1, 2, 3, 4 and a half. Okay. Flip back over. I have my x and y intercepts. What do I find after I find my x and y intercepts? Look, this is your vertical asymptote. How do you find your vertical asymptote? Set your denominator equal to 0. Now, the first thing you have in your denominator is that 2, correct? Does 2 ever equal 0? No, so that cannot be an asymptote. Now you have x minus 1 equals 0. When I have x minus 1 equals 0, I would do what? Add 1. So I have a vertical asymptote at x equals 1. And then I have x plus 1 equals 0. So my vertical asymptote is at negative 1. I just flipped them around there. Yeah. Okay. Top heavy, bottom heavy, same. Top heavy, bottom heavy, the same. What's my degree of my numerator? 2. Yes? Did everybody see that? What's my degree of my denominator? 2. Also 2. So that means they are the same. When they're the same, you divide your leading coefficients. My leading coefficient of my numerator is 4. My leading coefficient of my denominator is 2. 4 divided by 2 is 2. So I have a horizontal asymptote at y equals 2. How many pieces of graph am I going to have? 3, right? You can't go like here, 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 here. Take your vertical asymptotes and add one. That's how many pieces of graph you have. Because if I have a piece up here and I have a piece down here, it's not a function anymore. Because it wouldn't pass the vertical line test. It's not lame, it's awesome. It saves you a lot of work. Now, this one you don't have to do any you don't have to plug any numbers in for. So here's the deal. What's going to happen with this one is kind of going to go like that, yes? Pretend that I'm drawing it better. This one's going to go like this, yes? Yeah? Now, you usually don't cross over the horizontal axis. So this one in the middle is going to look like a parabola.
Also wasn't